And in this tutorial, we implement our RAG service based on the vectorless approaches. The decision for that is to stay fully based on the LLM output. So instead of using a vector-based techniques, we apply large language models to generate us the tree that structures the paper content, and using that content to supply for LLM for the further reasoning, question answering, and all other kind of discussions. And page index is one of the common solution for this is the vectorless RAG implementation. So everything that I mentioned is applied within this figure. So it generates the tree, and tree then can later be used for the reasoning purposes once applied to LLM. We're first installing this project, and the structure you can see on the left-hand side among all the content. For some of them I already identified, and docs folder in particular has been added. I have to quick to say that they have a lot of wraps around it, like the content with the cookbook that provides the Jupyter notebooks. They have a folder of examples and enriching their own RAG. But for today's content, the only thing that we need will be the run page index script. Let's take a closer look. This script provides numerous of the parameters that correspond to the setup of the trees that will be generated for the input files. It supports two types, so it could be a PDF file or Markdown. And similar settings could be customized within the page index folder in a YAML configuration file, from which mostly includes parameters where you can tweak the generated tree, depending on the amount of nodes that you need, tokens per each node, etc. And it also lists models that we intended to pick for our need. Among two models, we only need to customize the first one, as the second one corresponds to the RAG component. We'll stick to the ChatGPT 5.4 to generate the trees. The idea is to use the frontier models to produce high quality trees for the LLM when it comes to orchestration stage. Last comment is also to add, in order to launch this, we can see the dependencies in the requirements.txt, where and then one common is a LiteLLM, and it also has the python.env for launching your models, informally declaring everything in the environment. So I have the corresponding file in here where you put your keys to start up with the model. We're not going to go through all how to launch all of that, because the process is generally pretty straightforward. All you have to do for each your paper, launch this page index script by submitting the path to the corresponding file. However, and as I mentioned, I prepared the folder with all documents. So I put these documents papers. So instead of launching and applying them for each document individually, I created the script, used AI, and you can follow the same principle, which uses the run page index file and applies it for each individual file in the folder. So this is how the script looks. It just starts with preliminary checks, and then depending on the format, it passes the correct flag and launches the process. And this is how it looks on another tab. Once we started the script, for each document in the folder, it performs the construction of the tree with the corresponding long output in the end. The results is the folder where you can see the output, and each output represents the JSON file. Let's take a look quickly on the structure that we have. So it has the name of the document and structure listed as nodes. Each node has identifier, and nodes can have a subnode with the quick summary onto the nodes. So again, it's the recall to the settings in order to customize the tree you're willing to generate, whether it's going to be longer or shorter. But the idea is that later we're going to use these files in our orchestration system and a part of the retrieval tools. At this point, I showed everything that we wanted to. So we're going to use these JSON files in the other project. So at this point, we're switching to the implementation of the retriever and other tools that we need to develop orchestration. And to orchestrate our vectorless RAG using the LiteLLM, the implementation is pretty straightforward, and it follows the ideas that we saw in our prior video on the deploying our first orchestration system. We have two tools that we provide in this example. So one tool would be our retriever that is based on the page index, and another is provide list of the available files or index set of data that is for our RAG purposes. So the only difference is that we provide information with those tools, while the remaining orchestration loop remains as follows. So we just query each line from the user, and upon its submission, we launching our orchestration loop and returning the messages completed by ChatGPT 5.4 system. Let's take a closer look how we create the corresponding functions. It follows the concept that we previously saw. We have input for the functions and output supposed to be our template JSON, where we are based on a page index. So we just simply refer to their location based on the doc ID file for retrieving the information. So we simply dump this file in the output. And as for the files retrievers, we just list all the available files in the particular directory, which is in our case is so as you can see similar here for these two tools. And now let's take a look how it works in action. Quickly follow up that for the debug purposes, I added extra 2 lines that will show us at which point we're initiating the tool call. So when we're chatting, we will see how often this happens and what kind of tool particularly this should do in our history conversation. And now we have all set to start our orchestration system. All the files that we previously generated were put into the data catalog. We have to just start the corresponding script. Finally, it awaits a query to submit. I can just first ask, as you can see, it initiates the query and lists us 5 available documents. And then I can ask, which is launches the tool that calls to the file retriever. We have to, at this point, clarify which document I want to use. Yeah, and then according to the output that we have for the documents related to the healthcare, it gives us 4 documents for which one they provides the assumption, like Simoval is dealing with NLP, and so the rest of the documents actually relevant. So among all these amounts, I think the itinerary 1 is not correct, while the remaining 3 of them has the related connection. And the one says just because of its archive document, can't tell us the content. We can ask one particular paper to gives us the topic which it describes. So for example, we can proceed with the following query saying it identified that even with the short snippet that refers to this document, it initiated the tool call and provide us that this topic is about the multi-dimension aspect-based sentiment regression, violence arousal task. In general, I must say it's pretty relevant to everything that is provided to reading. This particular example, you can see where we don't have to initiate the tool call again. It provides the extracted table from that paper, list papers. Again, this fetches again from the whole previous structure. So this one example where we extracting a summary of the paper, which is again pretty much has to say that it's aligned with the content itself. In that paper, we propose like 2-stage approach, and here's where it's summarized. At this point, it again queried the content and resulted in the number of page. I can't extract the page number because the structure don't include a diagram page figure locations. It has figure number 1, but it can't provide us the corresponding reference to it. In which page? As you can see, it's also provided a limitation. And it's also a nice follow-up by taking a closer look on that, yet though we don't have the corresponding mapping, which just says that otherwise I'll need access to PDF content to figure indexing extract. So this might be a good call to adding another tool that allows us to read the whole content, or at least a certain location. So it would be a bit more precise with responses, but it gives us an opportunity to provide the content from the papers, which is really good as a first step. And there's definitely room for these improvements, but at this point, we're going to stop the video. I hope that it was very informative for implementing your own RAG systems. Thank you for watching and see you in the next one.